Let's work through another spring problem. This problem states a 2 kilogram mass sitting on a flat surface with a coefficient of friction of 0.2 is attached to a spring with a spring constant of 25 newtons per meter. The spring is compressed 20 centimeters from its equilibrium position and the mass is let go. And we want to know what is the acceleration of this system. So let's start like we always do with force problems by drawing a free body diagram. Here's our mass. It is compressed. Delta x, let's see, it says 20 centimeters. But we want to use meters, so I'm going to use 0.20 meters. That's our spring. Adding the forces acting on it, and we know we have a gravitational force. We have a normal force. The spring is compressed, so delta x is to the right, so the spring force is going to be to the left. And we have a force of friction. Since it's matching the coefficient of friction here. And we're going to assume the spring is going to move to the right when it's let go, so the force of friction is going to act, or it's going to move to the left, so the force of friction is going to act to the right. Now I'm going to call, in this case, I'm going to call to the right, or left positive x. And I'm going to call out positive y. And looks pretty good so far, so we can start by writing our Newton's second law equations. The sum of forces in the x direction. Going to my directions, the spring force is positive, minus the frictional force, and that's going to equal m times a. And in the y direction, we have the normal force between the block and the surface, minus the gravitational force. And there's no motion up or down. All our acceleration is in the x direction, so these are going to be equal to 0. And then this tells us that the normal force and the gravitational force are going to be equal. So at this point, I'm going to use the fact that I have an equation for the gravitational force. M times g, again, assume I'm on Earth, and we can use the local constants. This is going to be 2 kilograms times 10 newtons per kilogram. And we have a weight of 20 newtons for this object. That now tells me what the normal force is, as it's equal to the gravitational force, that is also 20 newtons. Now we're looking for the acceleration, which shows up in our x equation, or sum of the forces in the x equation. To find the acceleration, we need everything else. We have the mass already, that's good. We don't have the spring force, and we don't have the friction force. But luckily in this case, we can find both of those. I can go to my friction equation. This is the force of friction is the coefficient of friction times the normal force. Well, I was given the coefficient of friction. I found the normal force using my y equation. So, this number is 0.2 times 20 newtons. Gives a friction force of 4 newtons. I also have a spring equation, which says that the force due to a spring is equal to k times delta x. The spring constant is given as 25 newtons per meter. Delta x is given this problem as 20 centimeters, but I'm going to use the meter version, so 0.20 meters, which gives me a spring force of 5 newtons. I can then use both of these back into my Newton's second law equation to finish this off. So the spring force of 5 newtons minus the friction force of 4 newtons equals the mass, which is 2 kilograms times a. Doing this nice easy algebra, I get that this object's going to have an acceleration, in this case, of 0.5